Next, we come to a section of solving linear inequalities in one unknown. And in this example, solve the inequality 4x plus 13 greater than or equal to 7 minus 2x and represent its solution on a number line. And we have 4x plus 13 on the left hand side and 7 minus 2x on the right hand side. And since this is minus 2x and plus 4x, so either we have to move 4x to the right hand side or move minus 2x to the left hand side. But since we don't want any negative x, if possible, we don't want any negative coefficient for the x term. So we choose to move minus 2x towards the left hand side. And then move plus 13 to the right hand side. And this will be 7 minus 13. And we have 6x greater than minus 6. Therefore, x is greater than negative 1. And to represent the solution on the number line, we draw the mark 0. And this is our number line. X is greater than or equal to minus 1. We have the mark minus 1. And since this includes the equal sign, therefore, this is a dot. This is represented as a dot, and we draw an arrow here. So the range of values of x which satisfy this inequality is on the right hand side of negative 1. And in fact, this range includes all the numbers which satisfy this inequality. For example, the number 0. If we substitute 0 on the left hand side, then 0 is greater than minus 1 is always true. Therefore, this range actually represents all the numbers which satisfy this inequality. And in fact, there is another way of doing the same problem. Actually, we can move plus 4x towards the right side. But this is a more difficult approach because if we move minus 4x to the right side, then we have minus 2x minus 4x. And then we have 6 is greater than minus 6x. And finally, we have to divide both sides by minus 6. But since this number is a negative number, so inequality, remember, if we divide both sides by a negative number, divide both sides by negative number, then we have to change the direction or reverse, change the direction of the inequality sign. Therefore, when we divide both sides by minus x, this becomes minus 1, and the right hand side becomes positive x. And the inequality sign has to be reversed. So therefore, we have x is greater than minus 1. So again, the answer is the same as the first method. But this method actually requires us to change the direction of this sign. And this is quite a bit difficult because it is very easy for us to overlook or just ignore the sign. So remember, there is a hint on solving inequality is that if possible, we don't want the coefficient of x is a minus number. We want positive coefficient for x. And for example 3, again we have a fraction on the right hand side. And the denominator is a negative number. It seems that we have to multiply both sides by minus 2 or negative 2. But again, if we do this, we have minus 2 times 9 minus x on the left hand side and 6x plus 1 on the right hand side. But since this is a negative number, So we have to change or reverse the direction of the inequality sign. So this will be greater. And we continue to simplify both sides. And again, we move plus 2x towards the right hand side. We have 6x minus 2x, we have 4x. And minus xt minus 1, we have minus 19. So x will be less than minus 19 over 4. And to represent the solution on the number line, it will be like this. X is greater than, and since this does not include the equal sign, so we draw a small circle here. So this will be our answer. But in fact, there is a even better way of doing this problem, because we have multiplied both sides by minus 2 to remove the denominator. But however, this is a negative number. We have to intentionally change the direction of this sign. So can we use a method that can free us from doing the reverse of the sign? And again, we have this method. 9 minus x less than 6x plus 1 over minus 2. In fact, to remove the denominator, we can simply multiply both sides by positive 2. So since this is a positive number, we have this. This is a minus 1 as the denominator. And we can continue to simplify both sides. And since 6x divided by minus 1, we have minus 6x. And plus 1 divided by minus 1, we have minus 1. And now we can move minus 6x to the left-hand side. So that, this will be plus 4x. And then on the right side, we have minus 19. Therefore, again, x is less than minus 19 over 4. And throughout these steps, we have never changed. We don't even need to think of changing the direction of the inequality sign, because we haven't multiplied or divided both sides by a negative number. We do this with only positive numbers. Okay, example number 4. And since we have two fractions here, we simply do something to remove both denominators. That is, we can multiply both sides by the LCM of all the denominators, which is 6. Therefore, we have 6 times this one on the left-hand side, less than 6 times this fraction on the right-hand side. So this will be 3 times 5x plus 8 less than 2 times 4x plus 25. And again, we come to a step where we have to move all the x towards one side of the inequality. Therefore, we move minus 8x to the left-hand side so that the left-hand side becomes 7x. And the right-hand side will become 50 minus 24. This will be 26. So the final answer is x is less than 26 over 7. Again, draw the number line to help us to visualize the answer. Okay. And finally, example 6. And this problem is a little bit strange. The price of box of a candy and the box of biscuits are $35 and $40 respectively. And Mrs. Swan wants to spend not more than $400 to buy a total of 10 boxes of candy and biscuits. And she also wants to buy as many boxes of biscuits as possible. But the question asks us how many boxes of candy should she buy? But she wants to buy as many boxes of biscuits as possible. So we can just write down candy will be $35 for each box, and biscuits is $48. And she wants to spend less than $400 in buying biscuits and candies. So let's just let the number of boxes of biscuits be x. Since she wants to buy as many boxes of biscuits as possible. And then the number of boxes of candy will be 10 minus x. And now we can find the total cost, which will be 35 times 10 minus x plus 40x. And this should be less than $400. And we can simplify this. 350 minus 35x plus 48x less than 400. And therefore the left hand side becomes 13x. And the right hand side will be 50. 400 minus 350. And therefore x will be less than 50 over 13. And since x represents the number of biscuits she should buy, so we can write down, let the number of biscuits be x. And now we can find that this is actually not an integer, but the number of boxes of biscuits should be an integer. So x will be 3, since this will be 3 point something. So x should be at maximum equals to 3. That is, she should buy as most as 3 boxes of biscuits. And finally, we can write down the number of boxes of candy. Number of boxes of candy will be 10 minus 3, which is 7 boxes.